Hey everybody, this is Dr. Ban, and finally got this YouTube video thing up and running. So very excited to start answering some of these problems for you guys. And the first problem that we're going to work on is a problem that we've worked on in class. It's this problem 1771, and so the problem states silver forms a sparingly soluble cyanide salt, silver cyanide, for which KSP equals 1.2 times 10 to the minus 16th. It also forms a soluble cyanide complex, AgCN2-, for which K form equals 5.3 times 10 to the 18th. The question is, how many grams of solid potassium cyanide must be added to 100 ml of water to dissolve 0.028 moles of silver cyanide? For simplicity, ignore the reaction of cyanide with water. Be sure to include all the cyanide that's added to the solution. So the first thing is that it states that we've got 0.028 moles of solid silver cyanide. And the question is, how many grams of potassium cyanide is needed to dissolve 0.028 moles of silver cyanide. And really it's asking how many moles essentially of cyanide. From the number of moles we can calculate the number of grams. So what we're going to try and do is calculate number of moles of cyanide. Okay, so we have essentially two equilibria that we need to consider, and the first one is the solubility product of silver cyanide. So we know that silver cyanide, solid silver cyanide, can very weakly dissociate into silver plus cyanide ion. This is aqueous, and this is aqueous. And the KSP for that is going to be the concentration of silver times the concentration of cyanide, and that equals 1.2 times 10 to the minus 16th. And then we also have this other complex ion that can form, the silver cyanide complex. So that's AgCN2-. And in order for that to form, you need some silver ion plus two cyanide ions. K form would be the concentration of silver cyanide complex, this complex ion dicyanide, divided by the concentration of silver times the concentration of cyanide ions squared. Okay, and we can combine these two equations, these two equilibria, and we can combine these two equations as well. So if we combine the equilibria, the silver would cancel out, cyanide would cancel out with one of the cyanide ions down here, and so you'd have silver cyanide solid plus cyanide ion is in equilibrium with silver cyanide. And the new equilibrium constant for this would be Kc, which is going to be the product of KSP times K form. Oh, and this value of K form is 5.3 times 10 to the 18th. Forgot to put that up there. 5.3 times 10 to the 18th. So if I multiply 1.2 times 10 to the minus 16th times 5.3 times 10 to the 18th, I get a new value, and that value is equal to 636. And that's going to be equal to the concentration of silver cyanide 2- minus divided by concentration of Cn minus. This is aqueous. This is aqueous. And all of this is aqueous up here. This is aqueous. Okay, times the concentration of cyanide. And that's my Kc value. Okay, and you could see that too if I multiplied just these two equations together. The silver would cancel out, cyanide would cancel out. You'd be left with this equation down here. Okay, so it states that we have 0.028 moles of silver cyanide. So initially, we draw our ice chart to ICE. Initially, we've got 0.028 moles of this. Okay, and the key point here is that if this completely dissolves, we would have 0.028 moles of silver. Okay, so so you would have 0.028 moles of silver, and you'd also have 0.028 moles of cyanides. So this is 0.028. This would also be 0.028, and this would also be 0.028. If this again completely dissolves, then we would have 0.028 moles of silver and 0.028 moles of cyanide. But that cyanide is going to again form a complex with this free silver, but especially if we start adding more cyanide, it's going to form this nice complex that has a very high K value, K form value, 5.3 times 10 to the 8th. So that's very favored in this direction. So the change in concentration, initially we don't have either of these two. The change would be, this would be plus X, and this would be minus X. But the concentration at equilibrium, this is going to be 0.028 moles. Okay, at equilibrium you're going to have 0.028 moles of silver cyanide. And what we need to figure out is how much cyanide needs to be present in order to fully complex the silver ion. So if this is minus X, that would be minus 0.028 moles. If X is 0.028, minus X would be minus 0.028. And we need to figure out the initial concentration. So that initial concentration we're just going to call Z. So the Z is the initial. Z is going to be the initial amount needed to complex. Initial amount needed to initial amount needed plus the amount that we've already got, 0.028, to complex the silver ion. So that ends up being Z minus 0.028. Okay, and we would take this value of silver cyanide and incorporate it over here, and this would be over here. So our Kc in this case is going to be 0.028 moles divided by Z minus 0.028 is equals 636. So we cross multiply, so we'd have 636 Z minus, so we're going to clear that out, 636 times 0.028, 17.808 equals 0.028. So we're going to add 17.808 we're going to add, in this case we're going to add 0.028 to the 17.808, 17.836. So 636Z. So we're going to divide 17.836 by 636. And that's 0.028. And that probably makes sense. You know, we need an additional 0.028 moles plus the 0.028 moles that we've already got in order to fully complex the cyanide. Okay, so that makes sense. And then we multiply this, so how many grams of KCN? So we need to know the molecular weight of KCN. And so KCN is equal to 65.1 grams per mole. That's the molecular weight. So this is moles. We're going to multiply that by 65.1 grams per mole, and that should equal about 1.8 something. So we'll multiply that by 65.1 equals 1.83, 1.826. We'll say 1.83. So that's and if we go back to our answer here, that's about the answer that they give in the problem. So hopefully that was helpful, and if there's more problems that you have that you'd like me to try to cover in a YouTube video, just email me, jim.ban@wichita.edu, and we'll get these straightened out, and we'll be working on some more. I'll be working on some more of these this afternoon, so we'll get these out to you guys. Bye.